Experimental design has the lab question, the methods and materials, the data and observations. The goal is to communicate what and how you did the data collection with enough detail so that someone else can follow your work easily. Data analysis in a lab context has a goal of communicating what and how you did the data analysis with enough detail so that someone else can follow your work easily. A discussion about sources of experimental error is essential. The other parts of the analysis section may include any or all of the following: graphing, problem solving, sample calculations, and/or quantitative error analysis, all of which I will teach you how to do. Arguing a scientific claim includes the claim, the evidence, and the reasoning. The goal is to communicate the answer to the lab question, the best evidence you have for that answer, and how those results relate to the known physics theory. Using feedback is where you annotate your lab, highlighting the changes you made from the previous lab. The goal is to communicate what changes you made, why you made them, and how you have improved over time. So when you hand in a quiz or a test, which I call checkpoints, you will get a score on each of the following 4 practices. First, creating explanations and making predictions. The goal is to show what physics you know and can apply from the current unit of study. The physics can take the form of overtly stated definitions, laws, mathematical models, equations, or relationships. For the next one, problem solving, the goal is that when you solve a scientific problem, you should show the process you used. This problem solving process includes givens and variables on a labeled sketch or illustration, relevant diagrams, the equations used, numbers plugged in, and an answer to the question asked with units on all values. Graph interpretation has a goal of overtly using features of the graph accompanied by an explanation to demonstrate your understanding of the physics. Features might include coordinate pairs, slope, graph shape, area, and/or y-intercept. When appropriate, a mathematical model is developed or interpreted. Some of these are more sophisticated than others, depending on the question. Graph creation, the goal is to overtly create a graph including all relevant features. This includes axes labeled with variables and units, a trend line, a descriptive title, plotted points, and any given or reference values on the axes to scale when appropriate. An overtly stated physics relationship is presented in the form of theory and/or mathematical model. So that's what you need for a test. When you hand in a project, you will get a score on each of the following 2 practices. First is engaging with content. The goal is to overtly encourage and develop creativity. Creativity requires flexible thinking, originality, fluency with concepts, and elaboration. The engineering design cycle's goal is to solve a real-world problem, generally by building something. The steps of the engineering design process include asking questions, brainstorming ideas, planning solutions, creating a design, testing and evaluating, then repeating this process through as many iterations as possible in the time provided to improve the product. You document all of your progress and thinking in a journal.